Now the very first element that we will take is what is known as independent voltage source, and this is denoted by a symbol which has a circle with plus and minus marked, and what is given is the voltage in this polarity, and that is equal to, let's say, some V0. Okay, so this has two terminals, and what this is saying is that the voltage source will maintain a voltage of V0 between this terminal and that terminal. Okay. Now, one of the things I have to mention before we go further is the convention that we will take for describing the currents and voltages of two terminal devices. So, what is done is to describe relationships between the voltage and the current. Now, the voltage, let's say it's defined with this polarity, that is, I call this terminal A and terminal B, and I define voltages with A being positive and B being negative. That is, I measure the voltage of A with respect to B. Then I will also specify the current that is going into the terminal A. Okay. Now, of course, it's understood that the same current will come out of terminal B. Now, we have to have this convention so that there is no ambiguity. Okay. Now, we know that a voltage can be measured of A with respect to B or B with respect to A. Similarly, current going into A can be measured or current going into B can be measured. Now, what is important is that the definition of voltage and current be consistent. So, if the voltage V is defined with A being positive and B being negative, then the current I is measured as going into the terminal A. Okay, and this is known as the passive sign convention. And for every element, we are going to use this. Okay, that is, the current I goes into positive terminal of V. What is meant is the terminal which is defined as plus while defining this voltage. Okay, so for the voltage source, I have to define the current as going into the positive of this V. Okay, now this plus and minus signs inside the voltage source only denote the definition. The value of V0 itself could be positive or negative. Again, this is some source of confusion. I don't necessarily mean that because I put plus on top and minus on bottom, this V0 is always positive. Okay, I could define it any which way. These signs are used so that I can use a consistent direction for voltages and currents. Okay, while defining them. So what this says is this terminal A and terminal B, an independent voltage source maintains terminal A above terminal B by an amount V0. The voltage at terminal A is maintained above the voltage at terminal B by an amount V0, and the current can be anything. Okay, it's not restricted by the voltage source. Is this fine? So that's like a source of voltage, and an analogy could be made to an infinitely large reservoir which will maintain its level. Okay. Now you can take water out of this reservoir, but it's not going to change its level because there is infinite amount of water in it. Similarly, a voltage source is a source of infinite amount of current. It can you can draw any current from it, but it will still maintain the one of the terminals to be V0 above the other terminal. Okay. Now it's very common to draw graphs of I versus V to obtain a graphical description of the same characteristic. Okay. Now I would like answers from the participants. What would this look like? The I versus V curve for a voltage source. Okay, there is a raised hand which I have approved. Please ask your question. I think somebody raised their hand in order to ask a question. Please go ahead. Okay. So a lot of people have answered this and it's pretty obvious. V equals V naught. That's all that's there to it, and I can be anything. So this will be a vertical line on the IV plane at V equals V naught. Okay. So this is the characteristic of a constant voltage source.